Welcome to Study Loop.
So first, to calculate the frequency of the oscillations in the circuit, we know the frequency is the angular frequency divided by 2 pi, and the angular frequency omega is equal to 1 over the square root of L times C, where L is the inductance and C is the capacitance. And therefore, we can calculate the frequency if we know the inductance and the capacitance to be 1 over 2 pi times the square root of L times C. And these are all known values, so we can calculate this frequency. So this is 1 over 2 pi times the square root. Our inductance is given as 0.28 times 10 to the minus 3 Henry, 0.28 millihenry. And our capacitance is given as 20 microfarads. That's 20 times 10 to the minus 6 farads. And hence we get the frequency of oscillations to be 2.13 times 10 to the 3 hertz. And this is simply 2.13 kilohertz. So now we have the angular frequency. Next, we wish to calculate the energy stored in the capacitor. The energy stored in the capacitor, U, is equal to a half CV squared. And again, these values are known, hence we can calculate this energy. It's a half times the capacitance of 20 times 10 to the minus 6 farads, we'll suppress the units, times the potential difference across the capacitor of 150 volts squared. Hence we get the energy stored in the capacitor to be 0.225 joules. So finally, we want to calculate the energy stored in the inductor. But we know that energy is dependent on the current. So we have to calculate current I, and I is equal to minus omega times Q times sine omega t. So we need to first find out omega and Q if we need to find the current. So first, omega is equal to 2 pi f. We've calculated the frequency, so this is 2 pi times the frequency we've calculated before, which of 2.13 kilohertz. We get omega to be 1.336 times 10 to the 4, and that's radians per second. Now that we have omega, we need to calculate Q, and Q is equal to C times V. So this is 20 times 10 to the minus 6 farads multiplied by V, which is 150 volts. And we get Q to be 3 times 10 to the minus 3 coulombs. So now we have a charge in the capacitor. And therefore, we can calculate the current from the equation above. So the current I is equal to minus omega, we calculated to be 1.336 times 10 to the 4 radians per second multiplied by Q, which is 3 times 10 to the minus 3. And this is multiplied by the sine of omega, which again is 1.336 times 10 to the 4 times time of 1.3 times 10 to the minus 3 seconds. And hence we get a current of 39.92 amperes. So now that we have the current, we can calculate the energy stored in the inductor. And the energy stored in the inductor U is equal to a half times the inductance L times the square of the current, I squared. And so this is a half times the inductance given, which is 0.28, times 10 to the minus 3 Henry, multiplied by the current, 39.92 amperes squared. And hence we get the energy stored in the inductor to be 0.223 joules.